Okay, so start with the questions. So the first question, it said, oh, number one, I'll see how clear the camera is. Okay, so it said there's four more girls and boys in Mr. Rob's class of 28 students. So what do we know? There's 28 students, and girls equals boys plus 4, and girls plus boys equals 28. What does this tell us? Two boys plus 4 equals 28. So two boys is 24, and boys equals 12, which means girls equals 16. So that's how you solve for the number of boys and girls. And so what's the ratio of the number of girls to boys? Well, that is 16 to 12, but both these are divisible by 4, so it becomes 4 to 3. So the answer to number one is B. Okay, any questions on number one? Okay, if nothing, I'll move on to two. This is, ignore the things you see through that, just some scrap paper. Number two. So George runs 1 mile to school. He leaves home each day at the same time and walks a steady pace at 3 miles per hour and arrives just in time for school. So what does that mean? He's traveling 1 mile at 3 miles per hour. What does this equal? This takes him 1/3 hour, which is equal to 20 minutes. Okay. Now we know on the second day, he walks the first half mile at 2 miles an hour. So we want to see how much time he spent walking slowly. So we have 1/2 mile over 2 miles hour. Once again, units cancel. Yeah. 1/4 hour was 15 minutes. So how much time does he have left? Well, he has 15. Takes 20 minutes to get there, but he's already spent 15. So he has 5 minutes left, which is equivalent to 1/12 of an hour. Okay, so now he has to travel half a mile in 1/12 of an hour. So we get 1/2 mile divided by 1/12 hour equals the time. I mean, not time, speed. And this is equal to 6 miles per hour. So it's just to B. And to see the whole thing again, we know he gets 20 minutes. He spent 15 minutes in the first part. That means he has 5 minutes left, or 1/12 of an hour. He has to travel half a mile in 1/12 hour, which is equal to 6 miles per hour. That's how fast he must run. Okay. Number three. So there's two ways to think about number three. If you know modular arithmetic, where you work with mod 3, I'll do that on this half. And the other way, if you don't know modular arithmetic, I'll do it over here. So if mod 3, we know if it's divisible, it must be congruent to, so let's just say whatever this number is must be congruent to 0 mod 3, or to be divisible by 3. And we know the divisibility rule for 3. If the sum of the digits is divisible by 3, the number is divisible by 3. So 4, 7 plus A plus 5 plus 2 plus B plus 1. What is this equal to? 7 plus 4, that's 11, 16, 18, 19. 19A plus B is congruent to 0 mod 3. Leaves us is 1 plus A plus B is congruent to 0 mod 3, which implies. So what does this imply? This implies that is congruent to 2 mod 3. Okay, let's look at the next number. 8. So we get 3 plus 2 plus 6 plus A B plus C plus 4. I forgot about that. It's congruent to 0 mod 3. So what do we know? Let's see. This sums to 3, 2, 5, 11, 15. Get A plus B plus C plus 15 is congruent to 0 mod 3. And what do we know this equals? A plus B plus C is congruent to 0 mod 3. But from here, we know A plus B equals to 2 mod 3. So we go A plus 2 equals 0. This should be C mod 3. So I'm just going to write it over here, which implies C equals 1 mod 3. So which one of these numbers are 1 mod 3? 1. And the other way, if you don't know modular arithmetic, is you can just do it with the sums. So you know the sum of all the digits must be 3 for a number to be divisible by 3. So for number 3, so you get 7 plus 4 plus A plus 5 plus 2 plus B is 1. So we know this is 19 plus A plus B. So what does this tell us? A plus B. This must be equal to 2, comma. It could be like one of these numbers. Be equal to one any of these. I don't think I did. No, I didn't do addition right. So we know it's one of these. Okay. And we know it can be any one of these is correct. So let's just pretend A plus B equals 2 for simplicity. But you can substitute any of these and it'll be correct. And then look at the next one. You get 3 plus 2 plus 6 plus 8. B plus 4 plus C equals to 15 plus A plus B plus C. Okay? And now we now want this to be divisible by 3. We know this is divisible by 3. And A plus B, we said it was equal to 2. So I got 15 plus 2 plus C. So what can C to make this divisible by 3? Well, it could be 1, comma 4, comma 7. But the only one that's an answer is 1. So we know it's 1. Looking at the answer key, if you use a bit of reasoning, you can see that B equals 2. Answer B was 2, D was 5, but E was 8. So if B was true, all the rest would be true. So if you look at the answer, you can also eliminate B, D, and E, so you know it could only be A or C. Any questions on this? You don't have to understand this side, but this is something everyone should be able to do. But this side's a fancier way of doing it. And as you move up doing math, you'll shift more to this side of modular arithmetic. Yeah. And now we'll get to the harder questions. 4. So let's talk about a couple properties of a hexagon. I'm terrible at drawing, so here's drawing. So what do we know about a hexagon? Well, what we do know is a regular hexagon. It's actually made out of 6 equilateral triangles. So this is 60, 60, 60, 60. And what does this tell us? This angle is 120. And we also see the semicircle. Well, not semicircles, but like circle-shaped objects. And what are these? These are just portions of a circle that are 120 degrees. And this is, we know this is side 6, and these split it perfectly. So 3 and 3. Because it tells us in the question. So, and we want to find the region in here. So what do we know? We can find the area of the hexagon and subtract the area of these circular arcs. Now first let's find the area of the circular arcs. So we know each one is 120 degree section of a circle, but we know a circle is 360. So we just see what percentage of the circle they are. Each one is 1/3 of a circle, and there's 6 of them. So we know there's 2 full circles. And now what do we know the area of a circle is? Pi r squared, and we have the radius here. So the area of one of them is 9 pi, so the area of 2 would be 18 pi. Now we know the areas of the circle, let's find the area of a hexagon. So how can we do this? Well, we can do this by finding the area of an equilateral triangle. Let's think about this. So because this is equilateral, the angle bisector also bisects the sides perfectly. So this is S for side length. This is 30 degrees, 60, 90. And then we just know this is 1/2 s because it's an equilateral triangle. What does this tell us? We have s squared equals 1/2 s squared plus something squared. What is this x squared, which is this side? X squared is equal to 3/4 sine squared. So x equals √3/2 sine squared. Side. Okay, and now what do we know the area of a triangle is? Base times height. The base, this entire base, is the side length. And the height we talked about is √3/2 side. And always the 1/2. What does this tell us? The area of an equilateral triangle is square root 3/4 times the side length squared. And we know this is a hexagon, which is made of 6 equilateral triangles because it's regular. So we just multiply this by 6. And we get 3√3/2 side squared. Okay, that's the area of the hexagon. We know the side length is 6. It's 3, 3, 18, 54√3. And now we just have to subtract the areas of the circles. Minus 18 pi. And what is this? C. So, using Pythagorean theorem, we can find the length of this, the height of an equilateral triangle. And using that, we can find the area. But this is something you want to memorize. So this is the area of equal triangle is √3/4 side squared. This is something you want to remember. Okay. Question 5. That's a long question and it's a very difficult question. So I won't solve it here, but I'll upload a video to Google Classroom if you want to see the solution to problem 5. In the meanwhile, if you open Google Classroom, you can see what I put for today's assignment. I'll give you 20 minutes, so until 8:37 to work on classwork, week 2 classwork 1. Make sure to do the one that says classwork 1, not classwork 2. That's what we'll do after. But you have 20 minutes, so until 8:37 to work on the set of these 5 questions. If you finish early, you can send them. You can send them to me. And besides that, yeah, you can just work on them. And yeah, so. And if you finish early, work on the challenge questions. You're not supposed to be able to solve any of them, but they're just something you can think about. They're very difficult. But yeah, you can play around with those. You can try them. And if any of you manage to, I'll give you all week for these. If anyone can solve a single one, I'll be just astounded. Those are very difficult questions. Yeah, I'll give you until 8:38 to do these. And yeah. 8:38. Yeah, and work on those. 5 minutes left. Does I haven't seen many answers, so if you need more time, just write. You need more time in the chat, and I can push it back like another 5, 10 minutes if you need more time to work in the set. I'll push it back to 8:43. If you sent in set of answers, I'll start checking them. And now that it's actually slightly past 8:43, I'll go over the questions. So starting with question one, there's 11 games. So let's write these out. Make sure it's clear. Okay. And they're asking which one of these will change after we add 40? Just think about it. So 40, we know that the average is greater than 42 because that's the lowest number in the set, and the average is always greater than the lowest number. So if we bring a number lower than the average, it's going to bring the average down. So we know that the mean will not increase. In fact, the mean will decrease. Let's look at mode. What is the mode? 58. After we add 40, will it change? No. So it does not increase. The median, what's the median? Still got it? 58. After we add 40, will it change? No. Stays. But let's get the range. So it used to be 73 minus 42, 31. Now 73 minus 40, 33. See, there's an increase because 33 is greater than 31. So the answer is A, the range will increase. Okay. This wrong paper. Some of my papers. Recenter this. So with question two. So we have a isosceles triangle. Touch that. Okay. This is terribly drawn, but just bear with me. BAC 29, 29. What do we know about isosceles? This perfectly splits this in half. So this is 21, 21, and this whole thing is 42 because that's a property of isosceles triangles. This half and this half are exactly identical. And we know it's a right angle. That's the property of isosceles triangles. Okay? And we know this is a right triangle, and we want to find this. We use Pythagorean theorem. Okay. I'm going to just do a little quick jump with difference of squares. So, and the square root of 400 is 20. X is 20. This is 42. Area is base 1 times the second one. 1/2. Okay, 420. Answer is B. Was that too fast? Or did you get it? All right, any questions? Like, so this question is, you just got to remember, if you have an isosceles triangle, if you draw this line, these two triangles are always identical, and this is always a right angle. You need to know this tidbit of geometry if you want to be able to solve this question. Okay, this is a counting question. How many integers between 1,000 and 9,999 have four distinct digits? What does that mean? What does distinct digits mean? All of the digits are different. Okay? So, what does this mean? The first digit, it can be a 1, 2, 3, 4, 5, 6, 7, 8, 9, but it can't be 0. There's 9 options for the first digit. Okay, 9. Okay, now we used up one of these options, right? Now let's look at the second digit. 0 is an option now. So there's now 10 numbers we can choose from, except we already used up one. That means there's 9 left we can choose from for the next digit. 0 is still an option. So there's 10 choices, but we already used 2. So it's 8. Same logic for the next one. So we get 9 choices for the first number. Then we have 10 choices, but we used 1. Then we have 10 choices, but we used 2. Then we have 10 choices, but we used 3. you get 9 times 9 times 8 times 7. Because you have 9 choices because you can't use 0. 9 choices because you added 0 in but lost 1. 8 choices because you had 10 numbers but you used 2. And 7 choices because you have 10 numbers and you use 3. And this, let's see. This is equal to, I think, 4, 5, 3, 6. So the answer is B. It can't be 10. For anyone who put C, it's because you forgot that the first number can't be 0. But once you catch that mistake, you get this. Question 4. So this is a Venn diagram. 180 students voted in 2 issues. So you know that the total, 198, right? So 149 voted in favor and 119 voted in favor on the second. And there's exactly 29 who voted against both. So let's build a Venn diagram for voted against. Okay. So we know the total in A, right? And we know 29 voted against both. But we know that, so this is the first issue, this is the second issue. The total that voted no in A go to 198 minus 149, which is equal to, what is this? 49. And we know 29 voted no in both, which means 20 voted no only in the first one. Same logic for B. You get 198 students. And 119 voted in favor. So if we subtract, how many voted against it? 79, which means 50 voted against it. So how many students voted in favor of both issues? So we know there's 198 total students. And we have to subtract all the students who voted against at least once, which is 20 minus 29 minus 50. What is this? 198, 99, 99, D. This is just a Venn diagram. So you find how many are in the middle of voted against one of the issues or the other. And then you have to subtract to find how many people in total voted against the first one. Because, 29 voted against both. So then you have to calculate how many voted only against the first one, which tells you 20. And then you have to do the same thing for this one by doing the subtraction. And you find out that 50 people voted against only this one because they summed to 79. And now we need to find the people who voted yes for everything. So 20 people voted no for A, 29 people voted no for everything, 50 people voted no for B. So we sum these together for the total amount of people who voted no at least once. We subtract, we get D for 99 people who voted yes for everything. Now to question 5. A baseball league consists of two 4-team divisions. So I'm going to name these 1. The teams are going to be 1, 2, 3, 4, and A, B, C, D. Each team plays every other team in this division n times. So 1 would play 2, 3, and 4 each n times. And plays every other and plays each team plays every team in the other division m times. And n is greater than 2m, and m is greater than 4. So let's calculate the total number of games. There's 76. So say we had n games played in its own division. For every one, you play 3 teams, right? So say we're team 1. We play 2, 3, and 4. So if we play our own division 8 times, it's 3n because we play 2 3 times, 2 8 times, 3 8 times, and 4 8 times, which is 3 times whatever number we're playing our own division. Now the other division, say we're 1. We play them m times. We play A m times, B m times, C m times, and D m times, which equals 4m. So what does this tell us? 3n plus 4m equals 76. Okay? And what else do we know? M is greater than 4. So the smallest m can be is 5. And n is greater than 2m. So the smallest n can be is 11. So let's test the smallest case and see what this gets us. 33 plus 20, which is equal to 53. We're way too small. So let's think. What can we do? So say we play another game in our own division. 6. What does this mean? This has to grow to 13. If we play 6 in our own division, we play 24 outside our division, I meant, and 13 in our own division times 3, 39. What does this give us? I don't think I added right. No, I did. This gives us 63. Let's try again. Let's go up one more time. We play 7 games outside teams in our own division, which means we have to play 15 in our own division. What does this give us? 28 plus 15 in our own division, 45. What does this sum to? 73. Now we're only 3 away. How can we get 3 more games? Well, we know n increases every time n increases. This increases by 3. So if we make n equal to 16 and m equal to 7, we get 48 plus 28, which is 76. Which means we play 48 games in our own division. The answer is B. So the only trick to this question is, well, you just set up the equation. You need to find this equation. By reading the question, you can understand what we can solve for, which is this equation. Why does it have to be 13 and 15? Oh, because we're just testing the smallest possible case. So we know 5 is too small. So we don't have to increase this. We can also just increase this one purely. And yeah, you can just increase this one purely also. So you can just do without regard to this. You can increase this side also. But then but then it just gets messy and you realize that this increases it by a multiple of 3 every time. 76 is equal to 1 mod 3. What you have here isn't 1 mod 3, it's 2 mod 3. So increasing this any number of times will never get you a 1 mod 3 number because you're adding something to a 2 mod 3 number. Which means you also have to increase the 4. Because after increasing it, you get to 0 mod 3, and one more time you get to 1 mod 3, which is what you need, and you can increase by 3s. So we didn't randomly choose 13 and 15. 13 is the smallest possible number that's allowed once we increase to 6. Because remember, n is greater than 2m. So say if we make m 6, this has to be 13. 13 is the smallest possible number we can choose. If this is 6, 13 is greater than 12, and this is the smallest number that satisfies it. And same with 7. We get n is greater than 14, so n must be 15. Because it's stated in the question, n is greater than 2m. Does that make any sense? Okay. I'll give you guys a 5-minute break, and we'll reconvene at 9:02 to look at the last few questions. Okay, let's reconvene. You guys have until I mean not 9:22 to do the next set of questions, and then I'll go over them, and that will be it for today. This set question five, that's a tricky question. Question five, don't worry about if you can't do it. The other ones, pretty doable. One of the numbers I forgot to type in. Give me a second. I'm going to fix that right now. I just saw it on question four. Give me a moment. I'll fix that right now. That should say four. Some of the socks cost $4. Okay.
Classwork 2.
Yes, classwork two. For those who have sent answers, I'm starting to send back corrections. Okay, for those who just sent, let's see, they got a lot of messages in the last couple seconds, so I don't think, yeah, I won't be able to check them, but you can just check them to what I have because I got like 7, 8 people send them all in the last second. So if there's more time today, I'd message you back. But if you need help, you can just stay after class. I'll be here for a couple minutes. But let's start with question one. Gonna get a move on. Not too much time left. So what do we know? Let's see. This is A, B, C, D, E, F, G, H. So we know this is one with this. This is an octagon. So this is 1/8,
Your
1/8.
screen that well. We
Is
can't
it
see
not
your screen
focused?
that well.
I forgot to focus it again.
Okay.
Okay, thanks. Okay, as I was saying, we have a hexagon, which is A, B, I mean, octagon, A, B, C, D, E, F, G, H. And we know this is 1/8, 1/8, 1/8. And we know this is shaded. And this is half of 1/8 because we just cut this triangle in 1/2. So it's 1/16. So we get 1/8 plus 1/8 plus 1/8 plus 1/16 because it's just half of it. So that just equals 7/16, which is D. Okay. This one, you just need, it's an octagon, it's triangle, so you know 1/8, 1/8, 1/8. And then you see this is half of a triangle, so you know it's 1/16. So just a bit of addition of fractions. You just got to realize it's 1/8 and 1/16. Okay, number two. So each of two boxes, so I'll draw this for us, contains three chips numbered 1, 2, 3. A chip is drawn randomly from each. And they're asking us what is the probability that the product is even. So we have an easier way. Let's find the product probability that the product is odd, because we know that 1 minus the probability that it's odd equals the probability that it's even. So there's only one way to make an odd number. Odd times odd is the only way to make an odd number. So what is the probability we draw an odd number? 2/3. Probability we draw an odd number. 2/3. So it's a total probability that the number is odd. 4/9. So the probability that the number is even, 5/9, and that corresponds to E. For everyone sending 4/9, you accidentally found the probability that it's that it's odd instead of even. Even is 5/9. Sorry if I'm going a bit fast. I just don't want to hold you for too long. 3. So a number of sixth graders are paired with a ninth grade student as a buddy. No ninth grader assigned more than one sixth grade buddy. So 1/3 of ninth graders are paired of 2/5 of sixth graders. What does this tell us? 2/5 ninth equals, 1/3 of a ninth graders equals 2/5 of sixth graders. So what does this tell us? Multiply both sides by 3. The total number of ninth graders equals 6/5 the total number of sixth graders. So the fraction of the number of sixth and ninth graders that have a buddy. So the fraction of ninth graders plus sixth graders that have a buddy is what they're asking. It's this number over the total number, which is the ninth graders plus sixth graders. Because the fraction of something is just part over whole, the number that have a buddy and the number that don't. The total number. But what do we know? N equals 6/5 S. What does this tell us? We get 2/5 S plus 2/5 S over S plus 6/5 S. What is equal? 4/10 S over 11. This should be, I don't know why I added the 5. 4/5 S over 11/5 S. The 5's cancel. Which equals 4 over 11. And the S's cancel. So 4/11ths. B. So what is this? What is this question? It's just 1/3 of ninth graders equals 2/5 of sixth graders. And if we move things around, we know that the ninth grade population is equal to 6/5 the population of sixth graders. Then it wants us to find the fraction that have a buddy of both. So we gotta add the number of ninth graders with a buddy and the number of sixth graders with a buddy over the total number of ninth and sixth graders. And then to make these all same terms, we know that n equals 6/5 S, and we just substitute 6/5 S for all the n's, and then We get 4/5 s over 11/5 s, which becomes 4/11. Number 4. So he bought 12 pairs of socks and he bought at least one pair of each. The $1 socks, let's call them A. The $2 socks, let's call them B. And the $3 socks, let's call them C. How many pairs? So pairs of A, pairs of B, pairs of C. So the total number of pairs is equal to 12. Let's find the total cost. A, these are $1 socks. So, but these are $3 socks. So 3B. So for every one sock, it's worth $3. And the same for C. 4C equals 24. We have a system of equations and we want to solve this. So what do we see? Oh, we can bring this down and subtract it. And what does this give us? 2B plus 3C equals 12. And now what do we know? We know that B and C cannot be 0. Why? Because we bought at least one pair of each type. And what else do we know? B and C can't be negative. You can't have a negative number of socks. You can't buy a negative number of socks. And you know they can't be fractions. You can't buy 1/3 of a pair of socks. So what does this tell us? That these are both greater than, they both can't be 0, and they're both whole numbers. So what is the solution to this? Well, if B is 1, C is not a whole number. So the only solution that we see is B equals 3, C equals 2. Because if C is 1, you can't make even plus odd is not even. And if C is 3, even plus odd is not even. So this is even plus even, which is 12. So we know he bought C. So that means now we can find A now. A equals, and now 3B, because we know that's B. So we spent $9 on those socks, plus $8 on these socks, equals $24. So we get A plus 9 plus 8 equals 17. So you get A equals 7. So which means it's D. He bought 7 pairs of socks that cost $1. Okay? And these are my papers again. Up on the back. I'd have to refocus the camera for this. Okay. Now on to number 5. So we have a square. And we cut out 1-inch sections on each. That was a terrible cut. Okay, so now this is 1, 3, 1, 3, 1, 1, 1, 3, 1, 1, 3, 1. And we find the maximum area that can fit in the square. So I'm going to do a little trick here. I'm going to draw these lines in, right? So what do we know is in here? It's a 3x3 square, right? And now let's draw this square, the full square. And these are right angles. So we see this entire middle is in here, right? If the entire center is in here, this is an area of 9. And then you have to add the area of the small triangles on the outside. So let's take a look at these small triangles. Each one of these small triangles, we know that this is a length of 3. And we went over this is a height of 1. So what do we know? We have base and the height. So 1/2 base times height is equal to 3 halves. So you know each one of these has an area of 3 halves. So what does this tell us? You get 9 plus 3 halves, plus 3 halves, plus 3 halves, plus 3 halves equals 15. We have an area of 15, which is C. Because if you're thinking, it's not just this, we can tilt the square for it to fit in there. And then we don't actually need to know these lengths. You can find them. You can work with similar triangles. That's a nightmare. You have to solve a quadratic for that. But if you just look at this shape, you're like, wait, we have the base and we have the height. So I don't need to know any of this garbage. I just know that this base of 3, height of 1, area of each of these small triangles, 3 halves. Little geometry trick. Okay, any questions? If you don't have any questions, you're free to go for today. I'll post the homework probably tomorrow. Next class is this Sunday. And yeah, if you manage to solve any of the challenge questions, just send me your solution and I'll just be astounded if you can do it. Yeah, if you finish the homework, my challenge to you is to just try to solve a single one. Pick what the one you think is the best for you. Try to solve it. The answer to question one. Yes. Answer to question one. I can just do that question again for you.
Bye.
So
Thank you.
question one. See it. Question one, it was 7/16. See, I can pull up my solution
Bye,
for that one.
thank you.
Right here. One you break it into eighths, and it's 1/8, 1/8, 1/8. And it tells you x is at the midpoint, so you know this is just half, so it's just 1/16. Yeah, okay. See you guys.